So in this lecture, we're going to look at the java.util.function package, which was added in Java 8. Now that package contains functional interfaces that are meant to be used with Lambda expressions. Now the interfaces aren't meant to do anything specific. They represent the structure of Lambda expressions that are commonly used in Java. And you'll see what I mean as we look at some of the available interfaces. So we're going to start by creating a new project. I'm going to call this one Employees. It's going to be a regular Java project. Create the template which we normally do. So Employees is what I'm going to call it. Finish. And I'm going to open up in a new window, and that's because I'm going to copy some code from the current or the last project we worked on into here just to save a bit of typing. So the first one is I'm going to create a class in here called Employee. This is in the new project, and then I'm just going to swing over to the other project, and this is the Lambdas project we worked on in the previous video, and I'm just going to grab the code for that class. Now I'm just going to grab the entire code because I'm using exactly the same package name, and I can do that, come back over here and just select all and paste. And we're getting this error about Lambda expressions not being supported, so I just need to make sure that I'm running at the right language level. Open module settings, and I'm going to go to project and make sure we're on Lambdas version 8 for the project language level, and that should fix those errors. Alright, so that's fixed those, and the other thing I want to copy over from the other project is the code that creates and populates the list, and as well as the code that iterates over the list and prints out the employee's name and age. And that was in the main class, the main class from the Lambdas project. And so that's just this code here. So I'm just going to copy that and swing back over to the new project. And I think when copying, I accidentally copied the wrong file. So let me just fix that up again. So I'm going to go back. Well, what I'll do first is I'm in the Lambdas project. So I'm just going to copy that to the right place, to main. Right, I'm just going to undo these changes. Alright, so we've now got the main package. I'm just going to paste that in first. The code that I've copied and pasted. Alright, and that's going to have some errors until we copy the class over. Now I'm going to go back to employee again. And this time what I'm going to do, I'm just going to copy the class because we don't need all the other associated stuff there. So I'm just going to copy just that. Then I'm going to go back to the new project. I'm going to create a new class called employee. And then I'm going to paste this in over the top there like so. And I'll just make that a public class. So that's what I was trying to do the first time. Alright, that should have fixed the other errors now in main as well. And we're good to go. Alright, so just to confirm that it's working, let's just run this to see that it does work. And we see that we're getting the results that we talked about in the last video. And I'll just move the run window down to the bottom so you can see it a bit easier. Alright, and the code on screen you can see we use the for each method to iterate over the employees list. So if we put the cursor over the top of the for each, and on Windows I believe it's Control Q, and on a Mac it's actually F1. So if I press F1, you can see that I've got the documentation that's come up. So press that or Control Q depending on which operating system you're running. But we can see here that the method is actually looking for a parameter of type java.util.function.consumer and then a diamond, and we've got a super T in the middle there. So let's actually have a look at the consumer documentation to see what that's all about. And you can see on screen it says that this is a functional interface. And if we look at the section of the document above the method summary, this part here, we see that the function method is accept down here. Performs this operation on the given argument. So the interface has an additional method called and then down here, but it has a default implementation. So what that means is consumer has one method that needs to be implemented, and so it's a functional interface and lambdas can therefore map to it. Now according to the documentation, the accept method performs this operation on a given argument or on the given argument. But we're not actually calling accept though. We're calling for each. Now if we take a look at the code for each, and I'm just going to do an Alt Tab here to go back to our project. But if we have a look at our code for each, and I'm pressing either Command or Control, depending on your operating system, to have a look at the source code, if you click on that and have a look, you can see that for each method calls except, and that so it returns void. So what does all this actually mean? We pass for each a lambda expression that meets the requirements of the consumer interface. So a consumer accepts one argument and performs an action that doesn't return a value. Now it's called a consumer because it's object in, nothing out. Now this is perfect for when we want to do something like iterate over a list and print the contents. Now sure, we could write an old style for loop or an enhanced for loop to do the work, but doing it on one line of code is concise and clear. The lambda we're using takes an employee object, so go back to the code again. In the case of the for each, the lambda we're using takes an employee object and it doesn't return anything, so it matches what the for each method expects a consumer. Now when we call for each, it iterates over the list. On each iteration, it calls the consumer's accept method, passing the employee object as the parameter. Now the accept method evaluates the lambda expression using the passed employee object as the argument. The employee's name and age are printed to the console and nothing is returned. The employee is consumed and the iterator moves to the next employee in the list. Now as I said in the last lecture, there's quite a bit going on under the covers when we use for each, but essentially it boils down to the iterator calling the consumer's accept method for each object in the list. The accept method evaluates the lambda expression passed to by the for each method using the passed object as the argument. Now we've just seen an example of how the consumer interface is used. The java.util.function package contains over 30 functional interfaces. And don't worry, we won't actually be looking at all of them, but we'll touch on a few representative ones though. Before we move on, making sure that you're still in main.java, let's come over here to the lambda sender in the gutter over here. Now if you actually click on that, notice that it takes us to the accept method in the consumer class, just as we expected. Ultimately, it's the consumer, which was passed as the lambda expression, that does the work. So how else are the interfaces in the java.util.function package used? Well, let's suppose we want to print all employees older than 30 to the console. So what we'll do first is we'll add a couple more employees just to make it a bit more interesting. I'll close down this consumer file. So let's just add a few more here. Employee, red equals new employee, Red Riding Hood, 35. And one more employee, Charming, equals new employee, Prince Charming. All right, and down here we're going to do employees.add snow, for red I should say, and employees.add for Charming. So we've got a couple of extra employees there now. So let's start by using an enhanced for loop. So what we'll do is we'll just delete this for loop there for now, and we'll just create a new one. And we'll print out a list of what it's about. So it's employees over 30. And let's just print out a separator as well. Just some equal signs just to separate it. Okay, like so. And we'll start with an enhanced for loop. So for employee, employee, colon, employees. Then we're going to put if employee.getAge. If that is greater than 30, the age is greater than 30, we're going to print out a message, just the name. So employee.getName. So we run that. We should see, looking at the list here, we've got 1, 2, 3 employees that are 30 or above. I've got 3. I've got Red Riding Hood 35, Prince Charming 31, and Jack Hill 40. So that's correct. We're getting the results back for 3 there. So let's change this code now to use a lambda expression. So I'm just going to comment this code out for now, enhanced for loop. And we'll put the lambda above it. So we do something like employees dot for each. And that's going to be employee the arrow token, then we're going to open a code block, then we put our if in there. So if employee.getAge is greater than 30, print out the message employee.getName. Okay, we'll just run this again to confirm that it works. And we've got the same results, 3 employees. So once again, we've passed the for each method, a Lambda expression that meets the requirements of a consumer interface. But let's say we want to print out all the employees who are 30 or younger than 30. So let's actually do that as well. So we're going to leave that first one in there, but we're going to also create a second loop, which is for employees 30 and younger. So we're going to start out by printing out a message here. /enter, go to a new line. We'll put employees 30 and younger. Let's print another heading there just to separate it. Okay. So let's write a Lambda expression for that. So employees dot for each, and we're going to do employee again. We've got the arrow token. We'll create a code block. Then we'll put our test in there. If employee.getAge is less than or equal to 30, and print out the employee.getName. All right. So let's just run that and make sure that works as well. And you can see there that we've got both of them returning the right results there. So while that does work, we are repeating ourselves. So the only difference between the first and second Lambda expressions is the if condition. So what we could do is we could move the code into a method and pass a Boolean parameter that tells the method whether we want the younger or older employees. For example, we could pass a true if we wanted greater than and false if we wanted less than or equal to. It would work, but it feels like a hack. Perhaps there is a better way. And this looks like a great place to use the predicate interface that's built into the java.util.function package. Now the test method is the functional method in this case, and it accepts a predicate that returns a Boolean value. We can replace the if conditions we're using in our 2 for each calls with a predicate. So we're going to start by moving the code into a method called print employees by age, and we'll assume we want to print the older employees. So let's do that first. We're going to create that method. I'll just delete this extra code here. All right, so it's going to be private static void. I'll call it print employees by age. And it's going to receive as a parameter a list of our employees. And we'll assume it's going to be this code here. So we're just going to grab that code entirely, cut it out of there, and just paste it in. So I haven't made any changes whatsoever to that at the moment. And I'll also delete this second code block as well. Now we want to pass our employees over string as a parameter, so we're going to add that. We also need to somehow pass the condition we'll test the employee's age against, and that's where the predicate will come in. Now we can't use the for each loop because it expects a consumer. So instead we need to go back to using an enhanced for loop. So let's try that out and see what actually happens. So I'm going to change the parameters first. The parameters are now going to be, the second parameter is going to be string age text. And the third parameter is going to be a predicate of type employee. We're going to call that age condition. Then the actual code, what we're going to do there is we're going to change the hard-coded employees over 30. We're going to change that to age text. And then we need to change the lambda. And instead what we're going to do there is put a for using an enhanced for loop, employee, colon, employees. And then we can put if age condition dot test employee. Then we print out so I can delete the rest of this code there and leave that in there like so. Get rid of that as well. Okay. So our if statement is now using the predicate parameter. The for loop passes each employee to the predicate's test method, which in turn uses the employee as a parameter or as the parameter for the Lambda expression that maps to the predicate. So hopefully that sounds familiar. It's the same way for each it uses consumer. Now back to predicate, if the test method returns true, the employee will be printed. So let's now use the method to print out employees older than 30 and employees 30 or younger. And we'll add this code to the main method, just below the definitions where we've added the employees to the array list. And we can do that by calling the function print employees by age, passing the list first, and the message we want to show should be employees over 30. And the third parameter is going to be employee. And you can see we're writing a Lambda expression here, and it's going to be employee dot get age greater than 30. And then the second one, print employee by age, passing the list again. This time we're going to print the other message, which is employees 30 and under. Then the Lambda expression for this one is going to be employee and employee dot get age less than equal to 30. So you can see there that the predicate arguments are just Lambda expressions that match the predicate interface. Alright, so I'm going to finish the video here now. In the next video we'll continue on looking at this code, and we'll actually start running this and discussing the predicate a little bit further. So we'll see you in the next video.